Right, moments 3. The diagram shows a uniform rod AB of length 3 meters, mass 9 kilograms. So we've got all this information. Let's transfer all this into the diagram. So the rod is uniform. So halfway along the rod, we're going to put its mass, which is 9. So the force down is 9g. We've got a particle of mass 2 kilograms at A. So let's put a downwards force there of 2g. It's resting horizontally on its two supports, so we're going to put a reaction force where it's pushing down on the support is pushing back up on the rod. So that's R at P and that's R at Q. Okay, let's put the lengths in. We've got AP is 1.2. We know it's 3 all the way, so we know it's 1.5 to the centre, and if that's 1.2, then that's 0.3. We know that A to Q is 2.6. Now that already adds up to 1.5, so we've got 1.1 extra to make the full distance 2.6. And then we know that's 0.4, and then those two add back up to 1.5 as well, so that's all fine. So the first thing we have to do is calculate the reactions at P and Q. So our first job is to take moments. Let's take our pivot point at P. You could equally take it at Q. Moments about P. So as you've got this turning force with the pivot here, if you twist your pen, you'll notice that the RQ and the 2G arrow, they're pointing in the direction of the turn. So those two, even though they're pointing in opposite directions, are helping each other turn the same way. The 9G is the opposing direction turn. So I'm going to say that my force of 2G times a distance to the pivot of 1.2 plus my force RQ times a distance from Q to the pivot of, that would be 1.4, will equal 9G times a distance to the pivot of 0.3. Then we're going to work all that out. So 2 times 9.8 times 1.2 is 23.52 plus 1.4 reaction Q, and then we've got 9 times 9.8 times 0.3, which is 26.46. So if we subtract our 23.452 and then we divide that by 1.4, we'll just get our answer, which is 2.1. Now that's quite low, but that's because a lot of the mass is down at this end. Okay, so this force is going to be a much bigger reaction force than this one. Okay, to work out the other unknown force, we could take moments at a different pivot point, but it's easier and quicker to resolve vertically. Okay, so we can say that the forces up are going to balance the forces down. So we've got 2 forces up being equal to 11G going down. We've already got 2.1. So if we do 11 times 9.8 minus 2.1, we get our force at P. Okay, so they seem very different, those two answers, but as I said, that's because this is quite close to support P and you've got this mass here, so P is taking a lot of the weight here and Q is barely being used. For the part B of the question, it says when you've got an additional particle attached to point R, it's about to tip about P. So when you're thinking about this question, you need to think about where the pivot is, and here the pivot is at P. Okay, there is a support here at Q. Okay, if we're going to tip about P, it's not going to move that way because the support at Q is going to get in the way, so it must be tipping this way instead. Okay, which means that the additional mass must be somewhere on this side where I'm putting an arrow there. So I'll say that's 3G and I'll just call that distance X to the pivot. Okay, so Also notice that when you do a part B of a question like this, any answers that you found in part A are probably not going to be the same anymore. Certainly if they're forces, they're not going to carry on being those numbers, so don't use those numbers. If you've worked out a missing distance, then obviously you can carry on using that number. So here, when you've got a tipping question, what you want to imagine is that you've just put that weight just at the place where it perfectly balances. Okay, so imagine we've got our object and then we push down, okay, and we can just have it just at the point where it's not tipping, and I can take that support at Q away. And obviously if I pushed any harder, or if I moved that force further away from the pivot, it would then tip it up. So what we're going to say is, if it's going to pivot about P, then the Q is going to be 0. Okay, so the other support is not needed. Okay, and it's just like a seesaw balancing one support. So we set our equation up here and we take moments about P again. And we're going to say 2g times 1.2 plus 3g times x is equal to 9g times 0.3, and we'll just work it out and then we're done. Okay. 2 times 9.8 times 1.2. That was the 23.52 again. 3g is 29.4, and 9 times 9.8 times 0.3 is 26.46. We can work x out. That gives me x is 0.1. The distance it wanted was A to R, so it actually wanted this distance here. So if we subtract 0.1, we get the distance AR is 1.1, and we're finished.